This meeting is being recorded.
In Chapter 3, Problem 8, we're given some information regarding compound 1. So that's given down here. So this is compound 1 above where I just circled. This was isolated from Streptomyces bacteria, and it's shown some interesting properties. So they would like to investigate this a little further. And we're told here that it was prepared as its conjugate acid rather than its neutral form. So this shown down here would be its neutral form. And then we're asked to use these representative pKa values given down below that we'll talk about in a second, to predict whether the oxygen or the nitrogen atom would be more basic, and then which then would be protonated, right, to form the conjugate acid. So that's what we're asked to do at the end, would be to draw the conjugate acid of compound 1. So let's see if we can do this. So we add a proton and then equals the conjugate acid of 1. So let's look at these pKa values. So we see over here that the oxygen atom, if that were to be protonated, it would look like something like this. And that would have a pKa around negative 2.2. And then we compare that to a protonated nitrogen atom over here. That pKa is around 10.6. So if you remember the rules, the lower the pKa, the stronger the acid. So what we see here is that the nitrogen has a higher pK value, so it's more basic, and that would be the site of protonation, and that would be how we can draw this conjugate acid. So down here, hopefully this looks enough like the image above that you can see that that +1 formal charge is now on that nitrogen atom, and we have 2 hydrogens attached to it, and the other 2 bonds are in that ring. So nitrogen was protonated, it has a +1 formal charge. The oxygen was more acidic, so since it was less basic, it was not protonated in our conjugate acid sketch.